Hi friends, introducing a new lecture from Jnana Learning, Electronic Amplifiers. The contents of this lecture are Introduction, Characteristics of an Amplifier, Frequency Response of Amplifier, and Classification of Amplifier. Okay, so what is actually amplification? Amplification is the process of strengthening a signal by increasing its amplitude. Amplitude, frequency, wavelength, etc. are the important parameters or properties of a signal. So, amplification means simply strengthening a signal by increasing its amplitude. Okay. Now, electronic amplifier is an electronic device which can increase the power of a signal. It increases the amplitude of signal waveform without changing other parameters of waveform such as frequency or wave shape. Okay. Here shown the symbol of an amplifier where Vi represents the input voltage, Vo represents the output voltage, and Av, it is the voltage gain. Now we move on to the important characteristics of an amplifier. So the four important characteristics of an amplifier are gain, input resistance, output resistance, and bandwidth. And these four characteristics are defined in such a manner that the gain A, which is equal to V0 by Vi, should be large for an amplifier. And the input resistance, which is represented as Ri, should be large. And the output resistance, Ro, should be small for an amplifier. And finally, the bandwidth of an amplifier should be large enough. Okay, so these are the four important characteristics of an amplifier. Okay, now I will explain each of the characteristics in detail. So the first one, that is a gain of an amplifier, and already said that gain should be large. So what is actually the gain of an amplifier? The amplifying capability of an amplifier is described by its gain, and it is a dimensionless quantity. So three different gains are defined for an amplifier. That is first one, that is voltage gain AV, which is the ratio of Vo by Vi, that is output voltage by input voltage. And second one, that is the current gain AI, which is the ratio of output current by input current. And then we have the power gain AP, which is the ratio of output power by input power. So next characteristics, that is the input resistance. So input resistance is the ratio of input voltage to input current, and it is the resistance offered to the current into the circuit by its input side. And input resistance of an amplifier should be as large as possible in order to avoid loading effect. So what is loading effect? It is the reduction of voltage across a low value resistance when connected to a source having high resistance. And so in order to avoid this loading effect, the input resistance of an amplifier should be as large as possible. So I will make you clear the concept of loading effect with an example. Okay, consider the following parameters: Vs, which is the source voltage, Rs, internal resistance of the source, that is every source will have some internal resistance, Ri, that is the input resistance of amplifier, Ro, that is output resistance of amplifier, Vi, which is the input voltage to the amplifier, and Vo, that is the output voltage. Now first you consider that input resistance of the amplifier is some small value. Okay, and the values for the parameters as Vs, that is source voltage, is equal to some 10 volt, that is we are giving some 10 volt source voltage, and the internal resistance of the source as 1k, that is 1 kilo ohm, and consider that input resistance is 100 ohm. Okay, a low value. Now the input voltage to the amplifier can be calculated as Vs, source voltage, into Ri by Ri plus Rs. which gives a value 0.91 volt, which means that we are giving a 10 volt source and only 0.91 volt will be the input voltage to the amplifier. Okay, now consider that we are increasing the input resistance from 100 ohm to 10k. Again we have the source voltage 10 volt, internal resistance of the source 1k, and Ri, that is the input resistance of amplifier, as 10k, 10 kilo ohm. Now the input voltage Vi will be, that is 10 volt into 10k by 10k plus 1k, which gives a 9.1 volt. That is, if the source voltage is some 10 volt, we are getting approximately 9.1 volt as input voltage to the amplifier. Okay, that means the voltage increased to 9.1 volt from 0.91 volt when the input resistance of the amplifier increased from 100 ohm to 10 kilo ohm. This means that in order to avoid the loading effect, the input resistance of a circuit should be much greater than the source resistance. Okay, so that is the loading effect. So in order to avoid this loading effect, we have to increase the value of input resistance. Next characteristics, that is the output resistance. So output resistance, it is a total equivalent resistance at the output terminal of amplifier, and low output resistance is desirable in amplifiers in order to avoid loading effect when it is connected to another load. Loading effect we have already explained. And if output resistance is smaller than the load resistance, more voltage will be transferred to load from the output of amplifier. And the last characteristic is the bandwidth. That is, the bandwidth is defined as a range of frequencies in which amplifier provides the gain desired for it, and the amplifier should have high bandwidth. Okay, so the bandwidth should be large enough for an amplifier. So these are the important characteristics of amplifier. Now we move on to the frequency response of an amplifier. So the frequency response of an amplifier provides a picture of performance of that particular amplifier. Frequency response, it is the graph of frequency and gain of the amplifier, and no real amplifier has equal gain at all the frequencies. Okay, so here shown the frequency response curve of an amplifier. So it is a graph between the frequency and gain in dB of an amplifier. So in frequency axis there are two parameters, that is FL, which is a lower cutoff frequency, and FU, it is the upper cutoff frequency, and G represents the gain, and G minus 3 means the 3 dB less gain. Okay, so at the lower cutoff frequency and upper cutoff frequency, it is clear that gain have decreased by 3 dB. It is clear from the response curve. So there are some reasons for this decrease in gain by 3 dB at lower cutoff frequency and upper cutoff frequency. Now the frequencies between, that is the upper cutoff frequency and lower cutoff frequency, it is the normal range of operating frequency of the amplifier, and which is defined as the bandwidth of the amplifier. That is, FU minus FL is defined as the bandwidth of the amplifier. Okay, so there are some important parameters in frequency response curve. First one, that is a mid-band gain, and it is a gain of the amplifier in the middle of its normal frequency range, and in this range the gain will be usually a constant value. Okay, and the second parameter, that is upper cutoff frequency and lower cutoff frequency, which are represented as FU and FL in the frequency response curve. And we have already noted that the frequencies at which the gain falls by 3 dB from the mid-band gain, and that two particular frequencies are called as upper cutoff frequency and lower cutoff frequency. And the reason for this fall in gain is explained as, in AC coupled amplifiers and all, coupling capacitors or transformers are used to pass signal from one stage to another, and the presence of these capacitors reduce the gain at low frequency. And the presence of internal capacitance such as tray capacitance reduces the gain at high frequency. Okay, so that's why the gain fall by 3 dB at upper cutoff frequency and lower cutoff frequency. Now the last one, that is the bandwidth, which is the range of frequencies in which the amplifier provides the gain designed for it. Okay, it contains all the frequencies between upper cutoff frequency and lower cutoff frequency. That is, bandwidth is equal to Fu minus Fl. That is upper cutoff frequency minus lower cutoff frequency. So next is the classification of amplifiers. So amplifiers can be classified on the basis of various parameters. So we will see each of the classification separately. So first one, that is based on the input and output. So in that category we have got two types, that is a small signal amplifiers and large signal amplifiers. So small signal amplifiers means the main function of a small signal amplifier is to amplify weak electrical signals, and it can be classified according to 4 possible combination of input and output signals as voltage amplifier, current amplifier, trans resistance amplifier and transconductance amplifier. Okay, and the second one, that is a large signal amplifier or power amplifiers. It increases the power level of signal. Okay, its function is to increase the power level of signal. And on the basis of mode of operation, the large signal amplifier or power amplifier are further classified into class A amplifier, class B amplifier, class AB amplifier and class C amplifier. Okay, so these are the two categories under input and output type. Okay, and the second category is based on the classification based on the number of stages. So there are two types, that is a multi-stage amplifier and single stage amplifier. So multi-stage amplifier means the circuit contain more than one stage of amplification, and single stage means there will be only a single stage of amplification. And under multi-stage amplifier we have got 4 types, that is RC coupled, LC coupled, transformer coupled and direct coupled. RC coupled means coupling is done using a network of resistors and capacitors. That is, a coupling between the stages is done using network of resistors and capacitors. They cannot amplify DC signals as the capacitor block DC component of the input signal. And second one, that is a LC coupled, which means the coupling is done using inductors and capacitors. And transformer coupled means transformer is used to match the impedance or to decouple the parts of the circuit. And direct coupled means stages are directly coupled. Okay, so that these are the 4 types under the multi-stage amplifier. And next, which is based on the external source, that is we have the passive amplifier and active amplifier. So passive amplifier means actually step-up transformer is an example of the passive amplifier. That is, if an alternating voltage is applied to the transformer, large voltage signal is available at the output. Okay, actually it will do only the voltage amplification, no power amplification will be done using a passive amplifier. And active amplifier means it take power from an external source and use it to boost the input signal. Okay, so it is clear now the difference between a passive amplifier and active amplifier. And next classification is based on the frequency range of operation. So based on the frequency range of operation, we have 3 types of amplifiers, that is DC amplifier, audio frequency amplifier and radio frequency amplifier. So the frequency range of operation for DC amplifier is in between 0 to 10 Hz, and for audio frequency amplifier it will be in between 20 Hz to 20 kHz, and for radio frequency amplifier it will be between some few kilohertz to hundreds of megahertz. So it is based on the frequency range of operation of the amplifiers. Next classification is based on the bandwidth. We have narrow band amplifier and wide band amplifier. So narrow band amplifiers are mainly the RF amplifiers and wide band amplifiers are video amplifiers. And next classification is based on the active device used in the particular circuit. We have BJT amplifier and FET amplifier. In BJT amplifier, bipolar junction transistor is used for the amplification, and FET amplifier means field effect transistors are used over here in this circuit. And finally, based on the transistor configuration, that is a configuration of transistor used in the particular circuit, we have common base, common emitter and common collector. These are the three configurations in transistor. We will discuss it later. So based on the transistor configuration also we have three types, that is common base, common emitter and common collector. Okay, so these are the different classification of amplifier based on various parameters. Okay, so that's about electronic amplifiers. Hope you have got some idea about the electronic amplifier. So thanks for watching the video. For watching more videos and hitting your suggestions, please subscribe our channel Jnana Learning. Thank you so much.